Now, see here, the most important concept in electricity, instruments, experimental physics is number one, meter bridge, number two, potentiometer, number three, ammeter, number four, voltmeter. These four instruments, experimental physics, questions will come in NEET. Okay, so whatever the list I have given to you, the list of questions that is from previous year questions only. Okay, so here, how does this meter bridge work? What is the concept behind this? Meter bridge is working on the base of Wheatstone bridge. Here, Wheatstone bridge is having one resistance, another resistance, and this is one resistance, this is another resistance, and in the middle there is one resistance. This is called as Wheatstone bridge, where this is taken as P by Q and this is taken as R by S, isn't it? This is a Wheatstone bridge. And what is the middle resistance? It is called as a galvanometer. This is called as a galvanometer. So this is a basic principle behind this meter bridge. So what is this meter bridge? What you will do with this meter bridge? Let us imagine that I have given a wire to you. I have given a wire to you and I am asking you to find out what is the resistance of that wire. Okay, so what will you do? In this, there are two L-shaped strips, left side and right side. Middle one strip is there. Two L-shaped strips, middle one strip is there, like this. And there are gaps. Okay, so first thing is, here you keep an unknown resistance. Okay, this is called as X. Whose resistance you have to find out? I have given one wire. This wire you will fix here. And what you will do? You will keep one resistance box at this place, which is called as a known resistance. Which is called as a known resistance. This resistance box resistance can be adjusted according to your wish. It's a variable resistance. You can adjust that one. Okay, that is one thing. Now, here you'll draw one. This is a one wire. Okay, so this wire is of 1 meter. The name, which is called as meter bridge. Okay, so meter bridge itself says that it is having a length of 1 meter. Okay, so here the name meter bridge is given because here it is having a 1 meter wire. Okay, so now here this Wheatstone bridge, if you compare with meter bridge, what are the elements you are going to compare here? The first thing is this X is called as P, and this known resistance, this is called as known resistance box, which is given as Q here, isn't it? Now this is a 1 meter wire having a length 1 meter. You all know resistance is directly proportional to L. And in the middle, from the middle, you will consider one galvanometer. And this galvanometer is connected to one jockey. Okay, this is called as a jockey. And part of the wire is acting like Q here now. So this wire will help you to find out the balancing point for the left side. Now just see here. So this identity is applied only on balancing Wheatstone bridge. Now your Wheatstone bridge is meter bridge is balanced because it is showing zero deflection. Whenever it is showing zero deflection, that means it is a balanced Wheatstone bridge. It has reached the balancing condition now. We can apply the balancing condition where P by Q. Here P is P only and Q is nothing but L. And here R is nothing but P by Q and this is nothing but R here. Okay, and this is S. So I can write as R and S is nothing but the remaining length. Okay, so you might be having doubts. Sir, you are taking resistance here, but you are taking length here. What is the meaning of that? I told you that resistance is always directly proportional to length. The greater is the length of the wire, the greater is the resistance. This wire is also having resistance now. This wire is also having resistance now. So we can write P by R is equal to L by 100 minus L. That's it. So this is a condition where you are going to find out the unknown resistance. So in the place of P, you write X. Let us imagine this resistance box you have kept as 120 ohms. Okay, this is 120 ohms. That is known resistance. You have kept it 120 ohms. Let us do an experiment practically so that you'll understand clearly. So there is a known resistance which is 120 ohms, and this is unknown resistance which you have to find out. Now let us imagine this is showing a balancing length of 40 centimeters. This is 40 means this is going to be 60, which is 100 minus L, isn't it? So X, P is unknown and R, which is known here, you'll write 120 and L, which is 40 and the remaining thing is 60. So once you know the known resistance, once you know the balancing length, if you know, you can find out what is X here. So 1 times, it is going to be 2 times. So X is going to be 2 into 40, which is nothing but 80 ohms. You got an unknown resistance as 80 ohms. Hope you are understanding now. Is it clear? So that is the principle behind the meter bridge. Is it clear, all of you? So that is a meter bridge now. So once you understand a meter bridge, what is the function of a potentiometer? Okay, the next instrument which is called as potentiometer. So how does this potentiometer works? What is the use of this potentiometer? So meter bridge I have already explained. So this meter bridge which I have explained here, okay, one thing is, you can find out the unknown resistance. You can find out the unknown resistance. You can find out the specific resistance of that wire also, because unknown resistance is how much? Which is 80. So can you find out the specific resistance, which is R is equal to rho L by A? Yes, you can find out. Rho is equal to R into A by L, where which is A is nothing but pi R square by L. Okay, what is the radius? Is the wire. Okay, whatever the wire, thin wire you have been given, you have to find out the radius, first diameter and then radius of that wire by using a screw gauge. Wire is very small. We cannot measure with meter scale. You have to take screw gauge. First you will get diameter and find half of the diameter is nothing but radius, and you will find out the length of that wire also. Length of the wire by using the meter scale. Okay, length you will get, radius you will get specific resistance also, because resistance already you got it as 80. Okay, so 80 you will write, pi is 22 by 7, r whatever you have measured with the help of screw gauge, you will get that one, and the length of the wire also you will get. Then if you find out the resistance, you can find out even the specific resistance of that wire also. That is the next which I forgot to tell you. And what is a potentiometer? See, potentiometer is a device which is used to measure the EMF of a cell. I have given one cell to you, and that cell does not have any readings on that. 5 volts, 10 volts, 15 volts, 20 volts. Actually, it is mentioned on the cell. But I have given one cell in which nothing is mentioned, and you have to find out the EMF of that cell. For that, what are the things required? Let us discuss here now. First thing is, you should have one cell here which is called as a primary cell, and the internal resistance of that cell, and you should have a variable resistance which is called as a rheostat, and that is connected to external resistance, that is connected to an external resistance R, and this is called as a primary cell whose EMF is E, and the circuit is called as primary circuit. Okay, so what is this primary circuit here? Let me discuss about that. Let me try to make you understand primary circuit. If I want to measure your height, minimum 5 feet, maximum 6.5 feet will be the height of a class, even though if he is so height 6.5. What I should do first? I should have a primary measurements in my hand. I have to take one scale and draw the primary measurements on the wall first of all, from 5 feet to 6.5 feet. I'll draw the marking first. That is called as primary reading. Then I'll measure the height of each and every student. I'll call one student and make him stand here. Keep one pad on his head so that there won't be any personal error. Parallax error we say. That type of errors will be removed by keeping the exact pad on his head. We will see his height and remove. Next student will come. He is 6.2 heights. We'll keep the pad on him and see the reading 6.2. So these are called as secondary readings. Primary readings are already drawn on the wall. Secondary readings are each and every student I will call, measure and write the readings. So to measure the EMF of a cell, first of all you should have a primary reading. You should have a primary reading. So this is the length of a wire whose length is 10 meters. This length is 10 meters. So I have taken an EMF of a cell whose EMF is distributed among these 10 meters. There is every cell is having internal resistance. Every cell is having internal resistance. And where do that internal resistance comes? According to internal resistance, I told you yesterday that if a cell is considered, there is one plate here, there is another plate here, and this is connected to a bulb in the external circuit. This is a bulb which is glowing. Okay, so this is a positive, this is a negative, this is a copper plate, this is another copper plate, and which is dipped in a solution which is called as copper sulfate solution. And inside the cell, the current has to pass from where to where? Just see. The current has to, see, outside the cell, current will pass from higher potential to lower potential, and inside the cell the current has to pass through this. This is an anode, this is a cathode. Okay, this is an anode. The current has to flow inside from this wire to a copper plate. Again it has to pass through the copper sulfate solution. Again it has to come to the positive anode. Again it has to go like this. So during this journey, every cell is having a very less internal resistance, like how much? Less than 1, 0.4 amp, 4 ohms, 0.2 ohms, like that, isn't it? Every cell is having internal resistance in that. What is the meaning of resistance? Opposition to the flow of electrons takes place even inside the cell also. Outside the cell is a high resistance. Bulb is having a high resistance. So internal resistance, where do it comes? Because inside the cell also current has to flow from lower potential to higher potential, where EMF, electromotive force, is used, which is called as electrolysis process, will help you to create electromotive force. So this is the internal resistance of a cell, which is always denoted by small r. Okay, so internal resistance of a cell, which is always denoted with small r. So how do you find out this internal resistance? I'll give a small example for that. I'll give one small example for that. For example, this is a battery. This is an internal resistance of a cell, and there is an external resistance of a cell which is called as R. This is plus, this is minus, and this is an EMF of a cell, isn't it? So I would like to find out what is the current passing through that. So current, generally we write it as V by R, because V is equal to I into R. Okay, so I can also write current is equal to E by R net. Okay, V and potential difference is outside, EMF is inside. Both are having same units. Okay, if I take an EMF of a cell, you have to write E by R. If I take the potential difference outside the cell, you will take V by R. So if I take inside the cell, I'll write E by R net. So what is the total resistance in this? We can write this as total resistance is nothing but not only internal resistance, there is one external resistance also. We write it as smaller by capital R. Okay, so before, after that, you should know what is Kirchhoff's laws. What is the meaning of Kirchhoff's laws? It's a very important thing here. So Kirchhoff's first law, what does it say? For example, this is a junction in which two currents I1 and I2 are meeting the junction. I3, I4 and I5 are leaving the junctions, and this is called as a junction here. The sum of the currents meeting at the junction is nothing but I1 plus I2, which is equal to sum of the currents leaving the junction, which is I3, I4 and I5, isn't it? So this is called as Kirchhoff's first law. Is it understood to you? Then what is the meaning of Kirchhoff's second law? To understand the Kirchhoff's second law, you should know one concept. You should know some basic concept. What is that? Let us see here now. I have taken one resistance in which the current I is passing. This is the resistance R. You just remember only one thing. When current is passing like this, it means that this is called as a higher potential, this is called as a lower potential. If water is flowing like this, that means this is high potential, this is lower potential. In HU, whenever you see the current is flowing like this, remember that this part is higher potential, this part is lower potential. Okay, so just like water current, here electric current. Now here you are considering the loop direction, current direction, both are same. So if loop is also moving from higher to lower, just like try to imagine here. So what is the potential difference? This is higher potential, this is lower potential. So potential difference should be minus I into R in this case. Why it is minus I into R? I'll give one small example to understand and remember the concept. Water is flowing like this. You don't know swimming. Even though if you know little swimming, this is a flood water. You have been thrown in a flood water. Then you are also going along with the flood water, means you will not survive. If you go along with the water, you are going to die. So it is minus. You will get negative feelings. Negative here. So here, when you are going to, instead of promoting from lower class to higher class, you have been promoted from higher to lower. You have been sitting in 8th. You are made to sit in 7th. Demoted. So if you are going from higher to lower, means potential difference is negative here. Understood? So next thing is, for example, here this is the current direction and you are taking the loop direction. That means your direction is against to the current. See, water is flowing like this, means this is higher, that is lower. Current is flowing like this, means this is higher potential, this is lower potential. And you are going from lower to higher. You are able to swim against to the water. Current is in this direction. You are able to swim opposite to the water. That means you are a strong swimmer. You are a professional swimmer. Gajaitagadu vinu batkuto. Need enter water. Understood what I am saying now? So that means you are able to swim against the water. Your current is flowing like this. You are moving like this. Then the potential difference is going to be plus I into R. And you have been promoted from lower to higher section. There is nothing but positive feelings will be there, positive current will be there, positive potential will be there. Is it understood to you? So this is one example. Now, if you take a battery which is having positive terminal and negative terminal, your loop is like this. That means this is higher potential, this is lower potential. Bigger solid line represents higher potential. Smaller solid line represents lower potential. Your loop is from higher to lower. That means if it is an EMF E, you should consider EMF as minus E. Okay, for example, next situation, you are taking the loop in this direction where this is minus and this is potential, this is plus, this is lower, this is higher. You are going against to the from lower to higher. That means it's a positive thing. You have been promoted. So that means you have to consider here as plus E. This you should remember now. Understood what I am saying now? So let us take one small example here in which I have taken one battery. One battery I have taken, one small internal resistance I have taken, and there is an external resistance here. Okay, so what is the direction of the current? You know, the direction of the current is from higher potential to lower potential always. I told you. The direction of the current will be from higher to lower. That means here also current is flowing like this. Here the current is flowing like this. For example, you have taken a loop. Loop means the direction which you have considered according to your convenience. You have taken clockwise loop. So try to understand now here. So current direction, loop direction is same. Remember that you are flowing again towards the water. You are flowing along with the water, means negative feelings will come, means negative you should take. So here you should take minus I into capital R. So current direction is like this, loop direction is like this, means you are also going along with the water, means there is a negative feeling minus I into small r, and here this is negative, this is positive. It is going from negative to positive, means it is positive here. So which is equal to 0. This is called as Kirchhoff's second law, which says that the sum of the EMFs and the sum of the potential drops is going to be equal to 0. The algebraic sum means what? Either it is a negative or positive. You have to add them, and that is going to be 0. That is called as Kirchhoff's second law, which is algebraic sum of potentials, which is nothing but I into R, plus algebraic sum of EMFs is going to be equal to 0. Is it understood? So same thing I have applied. Now what I am going to get from this, E will keep like that only. These two I will send that side, going to be small r plus capital R. So I is going to be E by small r plus capital R. This is the current. Instead of doing all this, so I have just written I is equal to E net by R net, means total to resistance small r plus capital R. So this I have proved by using Kirchhoff's second law. That's it. Now, how to find out the internal resistance of this battery? Beside that battery, one small resistance will be there. What does it mean? That is the resistance of the battery only. So how are you going to find out the internal resistance of the battery? Yes, let me discuss about that. Log and put on internal resistance of a battery. So I just got I is equal to E by small r plus capital R, and you also know that I is equal to V by R. I is equal to V by R, isn't it? General formula, Ohm's law. I have taken here E by small r plus capital R. So I want small r. So I will take small r plus capital R by capital R is equal to E by V, isn't it? This small r plus capital R I have taken here, cross multiplication. This I have taken downwards. So I will divide partially. That means small r by small r plus capital R by capital R plus capital R is going to be 1. Partially division will be done. Here is going to be E by V. Okay, so small r plus capital R is equal to E by V plus E by V. It's going to be minus 1. This implies that small r is going to be, what is left now? E by V minus 1 into capital R. Okay, is it understood? So E by V. So you want to find out an internal resistance of a battery, then you should know what is the EMF of a battery. You should know what is the potential outside the battery. Then you will get internal resistance. And you should also know what is the external resistance of the battery. Hope you are understanding what I am saying now. Hope you are understanding. But what is the question before you know? What is the question before you know? So I have taken one battery having EMF. I have taken a battery which is having internal resistance R. And I have taken external resistance capital R. Okay. So what is the difference between EMF and potential difference? EMF means inside the battery. Potential difference means outside the battery. Potential difference means outside the battery is the potential difference. Inside the battery it is called as EMF, which is taken as E. Which is larger? Either E is larger or V is larger. So there are two cases here. First thing is discharging means what? Whenever you take a battery connected with external resistance, battery is continuously discharged. So if as soon as I remove the cell from a charger, it starts discharging. So whenever it is discharging, means from inside it is coming outside, you should remember that E is greater than V. So this is a case of discharging. What is this? This is the case of discharging. I'll discuss what is the case of charging also. So what is the meaning of charging here? So you have taken a battery, you have taken internal resistance, you have taken an external resistance here. No. So you just do charging here. No. This is called as charging. Okay. Charging at time. What is the meaning of charging? See, discharging means current will come like this from higher to lower. Charging means current will pass from lower to higher in the opposite direction. Here, current flows like this. Understood? There, current. See, what is the meaning of discharging means? As soon as you take a battery connected to some device, it starts discharging. It's a natural process. Charging means current will flow opposite direction. So it is flowing opposite direction. No. See, whenever it is discharging means battery is powerful, which is having more numerical value. E is greater than V. So the difference is going to be E minus V is equal to I into R. Okay. If you don't take any external resistance, you just take one battery, internal resistance is there, it is discharging. Okay. And here outside it is called as potential difference. Now, okay. No external resistance, only internal resistance. So it is current is coming outside. Discharging case. Discharging means what? From battery you are taking. Means battery is greater than you or not? Battery is greater than potential or not? You are giving to the battery is what? Battery low అయిపోయింది నువ్వు ఇస్తున్నావు దానికి అంటే బయట ఉన్న పొటెన్షియల్ ఎక్కువ ఉన్నట్ల సో therefore here E minus V is equal to IR. So just remember here there are some questions asked in just 2026. Discharging case is there in which he is asking what is an internal resistance. I have seen the question paper. He is asking to find out the internal resistance. It's very simple. Internal resistance is nothing but E minus V by I. Okay, so this formula framing is very important. It's very simple actually. Discharging means you're taking from the battery is greater than you. Okay, you're taking from the battery. Power is you are taking from the battery. E is greater than V. E minus V is equal to I into R. Charging means battery is dependent on you. No, battery is low. You have to supply the charge. Current flows opposite direction to fill the charge inside the battery. No, battery is charged means the outside potential is greater than EMF of your cell. So therefore, V minus E is equal to I into R here. Okay. So what are we going to get now from this? See, potential if you want to find out, it is going to be E plus IR. But basic formula is this one. ఈ రెండు గుర్తు పెట్టుకున్నాం అనుకో క్వశ్చన్ ఎట్లా తిప్పించినా ఇచ్చేస్తాం. అది గుర్తుండాలంటే ఈ చెప్పిన కాన్సెప్ట్ గుర్తుండాలి. డిశ్చార్జింగ్ అంటే E greater. Charging means V is greater. Okay, you have to charge the battery, it is low. From outside you have to charge it, means potential is greater here. So V is greater than E means V minus E is equal to IR. So what is the potential in the case of charging? E plus IR. What is the potential in the case of discharging? It is nothing but E minus IR. This positive sign, this negative sign is going to be very confusing here. But for that confusion, the basic rule is this one. Discharging means E minus V. Charging means V minus E is equal to IR. From this you can get what is V. Simple. Understood what I am saying now? So it's okay. Then we shall go for what is that? See here, this one. So this is called as a potentiometer. So from this potentiometer, the current is passing, okay? The current is passing through the internal resistance. The current is passing through the rheostat. The current is passing through the external resistance of a wire whose length is 10 meters. Hope you are understanding what I am saying now. Why I am taking current direction like this? Because current always flows from higher potential to lower potential outside the battery. So it's a higher to lower. So current is flowing like this. I would like to take a loop as you wish. You can take a loop anti-clockwise. You can take a loop clockwise. Both you can take. Anyone you can choose of your choice, but you will get the result as same. So let me take anti-clockwise direction and show you how it is going to be same now. This is going to be anti-clockwise direction. So your loop and the current is same. So minus I into RH. Minus I into small r, because current direction, loop direction same means you are going along with the water, you cannot swim. You are going to die. It's a negative chance. It's a negative feeling in you. So negative will come here. So minus I into capital R, and which is lower to higher means plus. For only EMF it is plus. For all the potential drops here and here, potential drop means IR. Potential drop means what? According to Ohm's law, it is going to be IR. That's it. So here is going to be 0 according to second Kirchhoff's second law. So therefore E is equal to, send the remaining things outside. and common out is I, which is small r plus capital R plus RH. So I is equal to E by small r plus capital R plus RH. What is this? This is called as current in a primary circuit. This is the current in a primary circuit. So I got the current in a primary circuit, but you should know what is RH is called as a rheostat. See, one thing you should remember here, what is that? Whenever you get one battery and along with the battery there is an arrow, that means it's a variable battery. See, fixed batteries are there, 5 volts battery, it's a fixed one. There won't be any arrow, but there are some batteries which is just like a box. You can change it. You can change the potential inside it. There will be knobs to increase from 5 volts to 10 volts or 10 volts to 15 volts. There is a variable one. Whenever in a symbol there is an arrow, that means it's a variable one. There is one resistance like this. It is a resistance R. It is called as a fixed one. It is called as a fixed one. There is one resistance in which there is an arrow. It is called as a rheostat. Means what? It is a variable resistance. Best example is your fan is having one knob. That knob you are rotating in an anti-clockwise direction, is you are increasing the resistance. Fan will go slow. You are rotating in a clockwise direction, means you are decreasing the resistance. Fan's speed will increase. The best example is the knob of a fan. Is it clear what I am saying? If it is a wall fan or a table fan, or it is a what is that fan? Vertically, the table fan is there. There will be one rope. If you pull like this, its speed will decrease. Once again you pull, its speed will decrease. Speed is decreasing means you are increasing the resistance. Means resistance is not fixed. It's a variable one. So whenever you get an arrow, you should understand that it's a variable resistance. Is it understood what I am saying now? Yes. So this is a primary circuit, isn't it? This is going to be the primary circuit here. So once you understand the primary circuit, now just see here. So in a potentiometer, internal resistance is there, EMF of battery is there, rheostat is there, resistance is there. This is all called as a primary circuit. Secondary circuit consists of one small battery whose EMF is small e. This is capital E, which is having certain internal resistance small r, which is connected to potentiometer, and there is one jockey is a metallic pen which is measuring the balancing point. Okay, let us take your height is how much? I have drawn on the wall as a height of 6.5 feet. So this battery is like a reference height. This battery is just like your height is finishing here only. From here to here, if it is 6.5 feet, you are coming and standing here, and your height is finished up to here, which is 5.5. Let us imagine. Understood? That means this is an EMF of a cell which you have to find out now, isn't it? So that EMF is along with the total length of this wire, which is taken as 10 meters. Let us take that length as L1. Okay, and this EMF of this battery, which is connected here, is showing the length as 6 meters. The total length of a wire is 10 meters. What does it mean? The EMF of a cell is distributed among 10 meters. The extra cell you have to find out. You don't know what is the EMF of this cell. What do you do now? The EMF you can find out now. It is showing 6. It is showing 6 meters means it is showing. It is nothing but what is that? It is nothing but 6 volts. Balancing length is 6. Okay, 10 feet, 6 feet. Okay, so like this you can measure. What do you understand from this? Okay, so E and this outside is called as the potential difference, which is taken as total length of a battery is L1, and this is taken as L2. Okay, but as there is an internal resistance here, what will you consider? So let us take here. Total EMF is nothing but E, and this is V. I told you that you can find out the internal resistance of this cell by using which formula? By using this formula. Okay, E by V minus here, minus 1. Okay, so let me show the next concept here. What is that happening now? See here. So I told you that internal resistance, what is the formula actually? I is equal to E by small r plus capital R. I is equal to V by R, which is equal to E by small r plus capital R. And this is the reference cell internal resistance, and this is a rheostat, and this is an external resistance. This is small r, this is RH, this is a battery which is connected to a jockey here, isn't it? This is a battery. It's having a small EMF E. This is having internal resistance R. You have to find out the internal resistance of the battery. How do you find out? Here. For that, I have taken this one. I have taken this small r plus capital R divided by capital R, which is nothing but E by small r, E by V. So small r by capital R is equal to r by r is 1. So which is nothing but plus 1, which is E by V. Small r plus capital R is equal to E by V minus 1. So this here I told you that E is directly proportional to L1. Total length of the wire is L1 and this is taken as L2. So E is directly proportional to L1. V means interpotential difference. So V is directly proportional to L2. E means distribute among all the total length. V means potential difference of this battery which is connected here. So that is directly proportional to L2. Total length is L1 and the balancing length is L2 here. So what do you understand from this? So instead of, this is one method. What is this? This is one method of finding the, internal resistance can be found by using the formula E by V minus 1 into capital R. But if you don't know what is the value of EMF, you don't know what is the value of potential difference, but you know total length is 10 meters and the balancing length is 5 meters or 6 meters, whatever it may be, 6 meters. So you got L1, you got L2 also. So small r is equal to L1 by L2 minus 1 into R. So this is the method to find out the internal resistance of a given cell. The first application of potentiometer is you can find out the EMF of a cell. How? Because smaller EMF by larger EMF is nothing but smaller length by larger length. Understand? Larger length is L1, smaller length is L2. You can write like this also. Capital E by small e is equal to L1 by L2. If L1 by L2 is greater than 1, what do you understand? That means external resistance is higher than the internal resistance. So external EMF potential difference greater than 1, and hope you understand now. Is it clear? So the first thing is you can find out an EMF of a given cell. Okay, so what is the next application of this? Next application of this is I have given one cell, I have given another cell which is E1, which is U2, E2. I have given two cells to you and I am asking which is larger, which is having greater EMF. There is no readings on a cell. For that also what will you do? You will draw a primary circuit so that it becomes habituated for you. Okay, and that too already manchi diagrams unnai. Okay, I've got a book in which colorful diagrams are there. I can write directly that one. But what is the use? You should know how I am creating the diagram. The more number of times I create the diagram, the more easier it is understood. So here, so this is the primary circuit. In the secondary circuit, I will take one EMF, another battery. I'll keep like this. Okay, there is a key here which is connected to the, what is that? Which is connected to the potentiometer, and here the jockey J1. J is there. Okay, so first what I will do, this is E1, this is E2. I have given you E1 and E2, I am connecting here. First, okay, so total length of the battery is taken as capital L, let us imagine. Capital E, capital L. Now, two different EMFs I have taken. So first of all, I will connect the key here and find out the balancing point, because galvanometer should show 0. Galvanometer box which is called as high resistance. Why will you take that box? So that galvanometer is very sensitive, it may not damage. It may damage. So to prevent the damage, I am taking high resistance. Okay, complex circuit. So I didn't take, but it should be there actually. So I have connected to EMF E. I will get the balancing length here. So I will take this length as L1 now. Second time I remove this connection from here and I will connect to the second battery. I am getting the balancing length now here. So this is the first J1 is the balancing length. Now J2. Now in the second case, I am getting the balancing length. I am getting the balancing length somewhere here. So first EMF balancing length L1, second EMF balancing length is E2. So I told you that E is directly proportional to L. So we can write E1 by E2 is equal to L1 by L2. If this is greater than 1, means upper one is larger and lower one is smaller. So if E1 by E2 is equal to L1 by L2, which is less than 1, what does it mean? It is less than 1 means denominator is larger, means E2 is larger. So this is the method to find out or compare the EMF of the two cells. This is the concept of potentiometer. So potentiometer, if it is understood to you, then what is the meaning of potential gradient? Okay, so what is the meaning of potential gradient is given by letter phi, or sometimes it is given by letter I. So in which the primary circuit is involved. There is a rheostat, there is an internal resistance, EMF, and there is an external resistance capital R. So I told you that the current will flow from higher to lower, and I also told you that current is nothing but E by small r plus capital R plus RH. I got the current now. Understand? What is the meaning of potential gradient is nothing but potential per unit length. Understood? For example, if 10 volts flow spread, okay, spread 5 volts spread. Understood or not? So potential per unit length means how much potential is spread in the how much length here, isn't it? That is called as potential per unit length. So once you get this one, so which is nothing but V and Amy, I into R by L. Okay, so therefore potential gradient I. So what is this? Potential gradient means V by L. So V is nothing but I into R by L. So phi is nothing but I. How much you got? E by small r plus RH. You'll write like that, and you'll write R by L now. Just like V by L is called as potential gradient, R by L is called as resistance gradient. In fluids chapter, you have taken V by L. Change in velocity with respect to depth. Here velocity will be 2 meters per second means inside the little bit depth if you go, velocity is going to be 1 meter per second. Means as you go depth, velocity is changing. That is called as velocity gradient, potential gradient. Understand? And now this is called as resistance gradient. Change in resistance with respect to length. See, larger the length of a wire, greater is the resistance. Lesser the length of a wire, lesser is the resistance. Because I told you, resistance is directly proportional to length here. Is it clear? So this is the concept of meter bridge and potentiometer. Let me take some gap. Okay.